Today, I'm going to be going over this problem. Given a string, find the longest palindromic substring. Some examples. Given BABAD, the answer is BAB or ABA. Given CBBD, the answer is BB. Let's begin with the brute force solution. The strategy will be to find all possible substrings and check if they are palindromes. We'll keep track of the longest palindrome we've seen throughout this process. Let's write the code. We'll initialize longest to the empty string to keep track of the longest palindrome we've seen. We'll create a double for loop to find all possible substrings. We'll check if the substring is a palindrome by checking if it is equal to itself reversed. This : -1 syntax that I used here is a Python trick for reversing a string or an array. If the substring is a palindrome and it's longer than longest, we'll update longest. When we finish the for loops, we'll return longest. Let's check our solution with the test cases. Looks good. The solution uses a double for loop, and within the nested loops, we perform an O of n operation to reverse the string and compare the characters. So the time complexity is O of n cubed. We can definitely find a better solution. A more optimal solution involves building palindromes from the middle out. We'll loop through the string, treating each character as the middle of the palindrome, and try to build up the palindrome by comparing characters on the left to characters on the right. The tricky part of this solution involves accounting for odd length and even length palindromes. Let's start by creating a helper function that will give us the start and end indices of the longest palindrome given the string and the index of the middle character. We'll check that the start and end indices don't go out of bounds and continue building the palindrome when the characters match. Once we've finished building the palindrome, we'll return the start and end indices. Notice here that we over-increment the indices, so we have to decrement them in the return statement. Now that we have our helper method, let's write the main function. We'll initialize the start and end indices of the longest palindrome to 0. We'll loop through the string and call our helper function with each index. When the length of the palindrome created by the helper function is greater than our current length, we'll update the start and end indices accordingly. Finally, we'll create the longest palindromic substring from the indices and return it. This looks right, but we forgot one key thing. We're only considering odd-length palindromes. We need to update our code to handle even-length palindromes as well. Let's update our helper method to handle even-length palindromes. Instead of taking just one index in the arguments, we'll now take two, since an even-length palindrome has two adjacent indices as the middle. We also have to do an additional check in the beginning of the function to ensure that the right index that's passed in is not out of bounds. Let's initialize start to the left index and end to the right index. Now, this helper method should work for both the odd and even length palindromes. With the updated helper method, let's update the main function as well. Let's update our call to the helper method with I as both the left and right index. Let's copy over this block of code for the even case. And pass in I plus 1 as the right index here. Now let's run the test cases. And they pass. This solution uses one for loop. Within the for loop, we create a palindrome from the middle out, which takes O of n time. So our time complexity is O of n squared, which is better than the brute force solution. There's actually an even more optimal solution to this problem using Maneker's algorithm, which runs in O of n time. I won't be covering that solution in this video, but I'll link the explanation in the description. Thanks for watching. I hope the video was helpful. I'll be releasing these videos weekly on Sundays. Subscribe if you want to get notified next time I upload. Thanks.